Welcome to solverfy.
In this problem, we're given two torque Rs. We'll call them torque RA and torque RB. So torque RA has the initial position S naught is equal to 15 centimeters. The initial velocity V naught equals negative 3.5 centimeters per second. And it has the acceleration 2.4 centimeters per second squared. The second torque R has an initial position of 10 centimeters and an initial velocity of 5.5 centimeters per second, but it has no acceleration. For the first part, we need to find the times at which the velocity of A equals the velocity of B. Now, note that there is no acceleration on torque RB, and it has an initial velocity of 5.5 centimeters per second. Now, since it has no acceleration, the velocity of B at any time is equal to its initial velocity, and that is just equal to 5.5 centimeters per second. Now, the velocity of A depends on time, and we'll use the kinematic equation. So V equals V naught plus AT. This formula gives the velocity as a function of time for any object undergoing constant acceleration. So V sub A is actually equal to V naught, that is negative 3.5 centimeters per second, plus A, that is 2.4 centimeters per second squared, times T. And we need to find the time at which VA equals VB. So we'll just substitute in VA is equal to VB, that is 5.5 centimeters per second. And we'll write the rest of the equation as it is. From there, we can just simply solve this equation. So we need to transpose 3.5 to the other side, and that will give us 5.5 plus 3.5 equals 2.4t, and that will give us t is equal to 5.5 plus 3.5 so 5.5 plus 3.5 divided by 2.4, and simplifying this expression will give us t equals 3.75 seconds as our answer to the first part. Now, for the next part, we need to find the velocity when at that time. So we need to find the velocity at t equals 3.75 seconds. Now, this should be simple enough. We can either substitute in t equals 3.75 into the formula for VA, or we can simply use the fact that the speed of object B is simply constant. So our required velocity is just the velocity of B at all points, that is equal to 5.5 centimeters per second. And we're done with that part. Now, for the next part, we need to find the times at which the cars pass each other. Now, for that, we need to find the equations for their position. So let's start with torque RB because that's simpler. So the position of any object that undergoes motion with constant velocity is the initial velocity plus, the initial position plus the velocity times the time. And we know that the initial position is 10 centimeters, so it's going to be 10 over here, plus the velocity, that is 5.5. So this gives us the position of B, S sub B, as being equal to 10 plus 5.5t. Now the equation for the position of an object that is undergoing constant acceleration is equal to s equals s naught plus vt plus 1/2 at squared. Now we can use this formula to find the position of torque Ra. So s naught was 15 centimeters, and the initial velocity, rather, it should be a v naught, should be negative 3.5 t plus 1/2. The acceleration is 2.4 times t squared, and this equation simplifies to be negative 15 minus 3.5 t plus 1.2 t squared. Now we need to find the time at which the positions of A and B are equal, because only when their positions relative to a common origin are equal will they pass each other. So let's find that. So that's 10 plus 5.5 t is equal to negative 15 minus 3.5 t plus 1.2 t squared. And that gives us 0 is equal to negative 25 minus 9t plus 1.2 t squared. And we can use the quadratic formula. First, we can rewrite this equation. So 1.2 t squared minus 9t minus 25. And our value for t can be obtained by using the quadratic formula. So that would be minus b. So that's minus minus 9 plus minus b squared minus 4ac. So that's minus 9 squared minus 4 times 1.2 minus 25 divided by 2a, so that's 1.2. And simplifying this with a calculator gives one value of t as being equal to 9.66 seconds, and the other gives negative 2.16 seconds. So we'll just go ahead and discard the negative value. So our required answer for t equals 9.66 seconds. Now, for the next part, we need to calculate the positions at t equals 9.66 seconds. So I'll use the equation for b because it's a lot simpler. So that's s equals 5.5 t plus 10. I switched out the order, but that doesn't matter. It's 5.5 into 9.66 plus 10. And that gives us the position as 63.1 meter, rather centimeters. Now for the last part, we need to explain the difference between questions A and question C. So question A was the time when, so both start some initial position and velocity. So A starts a bit ahead, it's traveling at s naught equals 15. B is a bit behind, and B is traveling with a constant velocity v sub b, but A has an initial velocity v naught and an acceleration. So in part A, we actually calculated the speed at which their velocities, so both were moving at the same rate. So both of them had the same speed at time t equals 3.75 seconds. However, at time 9.66 seconds, They both had covered the same distance relative to their starting point, and they were both equal to each other, and their displacements were equal to each other. They were level to each other, and they both passed each other at that instant. So that's the difference between part A and part C. And that is our entire question. Thank you for watching.